Hi, my name is Li Chen. In the next few minutes, I'm going to show you how to sort a list of numbers using quicksort algorithm. If you have any questions, feel free to break in and ask me at any time. Now let's start. As you know, quicksort is one of the most commonly used algorithms for sorting. It is a comparison-based divide and conquer algorithm. What it does is to divide a large array into two smaller subarrays, the lower numbers and the higher numbers. Then it recursively sorts the subarrays by dividing them to smaller arrays. But how do we divide them? First, we need to pick an element as a benchmark. We call these benchmark elements as pivots. For simplicity, we can just pick the first element as the pivot. Then we compare all the other elements with the pivots. The elements whose values are less than the pivot will be placed before the pivot and form the low subarray. And the remaining larger numbers will form the high subarray. However, moving the small number elements to the front of the pivot every time is not efficient in practice, because we will have to reindex all the elements on the path. Then how do we actually implement this? Let me show you with a general example. Here is a list of 8 random integers. To begin with, we set the first integer, 6, at the pivots. Then we start to compare the other elements with 6. During this process, we will keep updating the index of the leftmost high element. So later when a low element appears, we can simply swap its index with the index of the leftmost high element. So let's start with 3. 3 is smaller than 6, but since no high element appears yet, nothing happens. Then we come to 8. 8 is greater than 6, so 8 is a high element, and it is the leftmost high element. So we store its index. Then we compare 5 with the pivot. 5 is a low element, so we swap the indexes of 5 and the current leftmost high element, which is 8. Similarly, we swap the indexes of 1 and 8 because 1 is also a low element. Next, 9 is higher than pivot, so we don't have to move it forward. Just keep going. 2 is lower than pivot, so we swap it with the leftmost high element. Still 8. Now, leftmost high element changes to 9. If a low element appears later, the element will swap its index with 9. The last element is another 9. We don't have to do anything with it because it's on the right side. Finally, we swap the indexes of the pivot and the rightmost low element to finish this recursion call. Then, in the same way, recursion calls are made until the subarray is indivisible, which means there's only one element. There are a few ways to optimize the algorithm. First, we can use a better rule to choose a pivot. For example, the median of 3 rule. And we can also save the time of sorting the repeated elements by ignoring the elements that are equal to the pivots. The worst case big O notation is n squared. However, in practice, the average case big O notation is close to n log n, which is quite good. That's it for the video. Thank you for watching.